This video will focus on learning target. I can relate IMF to different physical properties of a substance. This video will focus on how solubility is affected by intermolecular forces. So solubility is when something dissolves, right? And to be able to dissolve, we know the process is kind of break and make. There has to be some kind of attraction between the two substances to make them intermingle. So the phrase we often use is like dissolves like. In order for a polar or ionic thing to dissolve, it has to have an attractive force to replace the attractive force that's being broken. Okay? So to be able to dissolve, essentially you need similar intermolecular forces. So polar and ionic substances dissolve into each other like salt into water, or beverages oftentimes are some kind of solution like pop. But you can also have dissolving of nonpolar substances. And essentially what's happening there is the intermolecular forces between, those London dispersion forces between the different nonpolar substances are getting broken and replaced by new London dispersion forces with the other substances. So a lot of times gasoline is a mixture of multiple nonpolar substances, or oils. You'll see like those mixtures of oils. Those are all dissolved essentially, and it's like dissolves like, so the nonpolar things will dissolve into each other. So here's a specific example, blown up big, of water and ethanol, which both are polar. Okay, water specifically has a hydrogen bond, but it doesn't matter. It's just about the charge attraction. So we have water, and they're all hydrogen bonded to one another, and then we have ethanol, and they're all hydrogen bonded and dipole-dipoled to each other. And then when we mix them, essentially some of water's hydrogen bonds break apart, some of ethanol's hydrogen bonds break apart, and they make new intermolecular forces with one another. So to be able to dissolve, there needs to be a force of attraction that's replacing the IMF that's being broken. So like dissolves like, they both need to have some kind of charge. If you look instead at like water and cyclohexane, cyclohexane is a nonpolar substance, so it only does London dispersion. And essentially then if you threw cyclohexane into water, it would mix with water, but it couldn't form any force attraction with water because it's not attracted to water in any way, shape, or form. So you'd see them kind of intermixed, and then over time they would simply separate based on density. You'd have one substance on top of another substance, and that's because they couldn't dissolve into each other. Okay, when water and isopropyl alcohol or something like that dissolve, they have different densities, but because they mix, they dissolve into each other, we don't see them. Because these are not going to mix or dissolve into each other, we actually see a separation. So IMF affects solubility because really it dictates how things dissolve. Like dissolves like, so if something has charge, both dipoles or ions, they will be able to dissolve each other. And if there's no charge or very small charge, like London dispersion, they will dissolve into each other. That's it. Have a nice night.